Changing a fraction to a decimal number is a skill that was included in the decimal section of the wiki. The lesson that I used was one from Math Antics called Converting Any Fraction to a Decimal, and you're welcome to review that lesson or listen to it again. I believe I also included it as on the percent wiki page so that you have a link to it there. But I'm also going to present my own version of changing a fraction to a decimal number in this lesson, so you can listen to this lesson as well as a review. Okay, so we know that, hopefully you remember that we use division to change a fraction to a decimal number. And when we're looking at a fraction, we're also looking at a division problem, because the fraction line can be used to express division. We can look at this 4 over this 10, and we can use fraction language and call that the fraction 4/10. Or using division language, we can look at this fraction and read it as a division problem, 4 divided by 10. So division and fractions are really closely bound up. In fact, in one way they're the same thing. The math of division and multiplication, for that fact, is closely bound up with fractions. Okay, so we're going to change this fraction to a decimal number by thinking about this fraction as a division problem, 4 divided by 10. So I'm going to do that division over here, and 4 divided by 10 would be written thus. The top number of the fraction always goes inside the box. When we set up our division problem, we see that the outside number is bigger than the inside number. The way to handle that situation is to add a decimal point after the whole number that's inside the box, and then once that decimal point is in place, we can add as many zeros as we want to after the decimal point and not change the amount 4. The amount 4 has to say 4 inside the box. We can't just tack on another 0 without the decimal point, because then we would have the number 40, and 40 is not the same amount as 4. Okay, so the decimal point is in place. I've added a 0 after the decimal point, so now I can think about dividing 10 into 40. I'll go ahead and put my decimal point up in the answer. That's the safest thing to do. And 10 divides into 40 exactly 4 times. So 4/10 is equivalent to the decimal number 0.4. And this is an example of changing a fraction to a decimal number where we only needed to add 1 0 after the decimal point. You never quite know what you're going to get when you do this division, changing a fraction to a decimal number. You never quite know how many zeros you're going to have to add, or if you're going to get, you can get several different situations, and so we're going to talk about those different situations as I go through this lesson. So in this case, all we had to add was 1 0, and the division came out even, and we're done. All right, now let's change 1/4. Hopefully you know that 1/4. You may know that 1/4 is equal to the decimal number 0.25. But let's go ahead and do the calculation. All right, so to do the division, the top number always goes inside the box. So the 4 goes out here. And of course, we've got the situation again where the outside number is bigger than the inside number. In order to divide, we're going to need to put our decimal point, and that allows us to add as many zeros as we want to after the decimal point. So I'll just go ahead and put 1 in. All right, decimal point in the answer is going to go straight up. 8 divides into 10 2 times. 2 times 4 is 8, so we have a remainder. Therefore, I'm going to add another 0, and my remainder, which is 2, I'm going to use short division and place the remainder 2 in front of the next 0, which turns this amount into 20. 4 divides into 20 5 times exactly. 5 times 4 is 20, no remainder. So the division comes out even. In this case, we needed to add 2 zeros after the decimal point. So we can say that 1/4 is equal to the decimal number 0.25. And now we get to the interesting 1/3, interesting because it's going to be a repeating decimal. And in the previous lesson on changing fractions to decimals, you worked this one out. I'll make my division box kind of long this time, thinking in advance about what's going to happen. The top number of the fraction always goes inside the box. I add my decimal point, so I can now add as many zeros as I want. Just anticipating what's going to happen, I'll throw in a whole bunch of zeros. Place my decimal point in the answer before I start to divide so I don't forget it. Then 3 divides into 10 3 times. 3 times 3 is 9, so we have a remainder of 1. 3 divides into this 10 3 times, with a remainder of 1. 3 divides into this 10 3 times, with a remainder of 1. And 3 divides into this 10 with 3 times with a remainder of 1. And this, no matter how many zeros we add, we will just keep getting 3's in our answer. So the way to express, there are actually a couple of different ways that you could express your answer to when changing 1/3 to a decimal number. The one nice way to do it is to only write one of the 3's and then put a bar above it. And then that symbol of the bar above that digit after the decimal point means that this is a repeating 3 and that it repeats forever. So that's a really nice way to express your answer to 1/3 equals what decimal number. Now, you could also switch from using the equal sign and use the approximately equal to sign and round the 0.33333s and so on to a number that where you just drop some of the 3's. So if I round to the hundredths place, since the digit in the next place over is less than 5, I'm not going to round the 3 in the hundredths place up to a 4. I'm just going to leave it as a 3. So we could say that 1/3 is approximately equal to 0.33. It would be false to say that 1/3 is equal to 0.33 because that is not true. 1/3 is only approximately equal to 0.33. 1/3 is exactly equal to 0.333333 forever and ever. Okay, so let's take a look at 1/7 and rewrite that as a division problem. The top number always goes in the box, so the 7 goes out there. I place my decimal point. I can now add as many zeros as I want. I'll just go ahead and throw a few in here. And I'll start dividing. place my decimal point in the answer first. Using short division, 7 divides into 10 one time. 1 times 7 is 7. So I get my remainder by counting up to 10. 7, 8, 9, 10. So I have a remainder of 3. Now 7 divided into 30 would go 4 times. 4 times 7 is 28. 28, 29, 30. So I have a remainder of 2. Then 7 divided into 20 would go 2 times. 2 times 7 is 14. Now to get the remainder, I'm going to count up to 20. 14, 15, 16, 17, 18, 19, 20. That gave me a remainder of 6. 7 divided into 60 would go 8 times. 8 times 7 is 56. 56, 57, 58, 59, 60. So I've got a remainder of 4, and I'm tired of dividing. So this is an example of changing a fraction to a decimal number where the division is not coming out even, and I don't want to keep dividing. So I can't just stop here and say that 1/7 is equal to 0.1428, because it's not. There are more digits that would come after the 8 that I haven't even figured out yet. So this is not a true statement. I can't just stop dividing, use my equal sign, and say that these two things are equal to each other. What I could do is use an approximately equal to symbol and round my answer. Since I've figured it out all the way to this place, I could round to this place, the thousandths place, and since an 8 is bigger than a 5, I'm going to have to round this 2 up to a 3. Then I can drop that 8. And then say that 1/7 is approximately equal to 0.143. So this is rounded, this is a rounded amount. When I am expressing a rounded amount, I have to use the squiggly equal sign, which means approximately equal to. Okay, I'm going to stop the lesson here, and the next lesson is we're going to go to finishing up, just about finishing up the big triangle, and moving on to changing a fraction to a percent.